The principle of redundancy is used when system reliability is improved through redundant or backup components. Assume that a student's alarm clock has a 16% daily failure rate. Complete parts A through D below. What is the probability that the student's alarm clock will not work on the morning of an important final exam? We're going to let A be the event that the alarm clock fails. So to convert a percentage to a decimal, we would say that the probability of event A is equal to 16%, which is 0.160. Thus, the probability that the student's alarm clock will not work on the morning of an important final exam is 0.160. Part B. If a student has two such alarm clocks, what is the probability that they both fail on the morning of an important final exam? Well, if we let A be the event of the first alarm clock fails, and B be the event that the second alarm clock fails, given that the first alarm clock has failed, then the formal multiplication rule becomes the equation below. Probability of A and B given is equal to probability of A times the probability of B, provided that A has already occurred. Now, the functioning of the second alarm clock is not affected by the failure of the first alarm clock, so by definition, A and B are independent events. Since the failure of the second alarm clock is independent of the failure of the first, we can say the probability of B, provided that A has already occurred, is equal to the probability of B. So the formula for the formal multiplication rule becomes a formula shown below. The probability of A and B is equal to the probability of event A times the probability of event B. Well, substitute the appropriate probabilities into the formula and then simplify to find the probability of both alarm clocks not functioning correctly. So we would say the probability of A and B is going to equal the first alarm clock that fails, which is the probability of 0.160, times the probability of the second alarm clock that fails, which is 0.160. Multiplying those two together, we get 0.0256. Thus, the probability that both alarm clocks will fail on the morning of an important final exam is 0.0256. What is the probability of not being awakened if the student uses 3 independent alarm clocks? Now we're going to let C be the event that the third alarm clock that fails. Recall that from Part B that the failure of one alarm clock is independent of the failure of another alarm clock, so use the formula for probability of A, B, and C given below. So the probability of A and B and C is equal to the probability of event A times the probability of event B times the probability of event C. So since we know that they're all equal to 0.160, to find the probability of not being awakened if the student uses 3 alarm clocks and then round it to 5 decimal places. So we know that the probability of A times the probability of B times the probability of C is 0.160 times 0.160 times 0.160, which gives us 0.00410. Thus, the probability of not being awakened if the student uses 3 alarm clocks is 0.00410. So let's take a look. The first one, we get 0.160. The second one, 0.0256. And the third one is 0.00410. For Part D, it says, does the second and third alarm clocks result in greatly improved reliability? Now, if we compare the probability of one alarm clock not working to the probabilities of 2 or 3 alarm clocks not working, in general, when an event will occur, the probability is 1. It is certain. An event occurring with probability less than or equal to 0.05 is called unlikely. And an event occurring with probability 0 is called impossible. So if we take a look at the second, this is less than 0.05, and this one is also less than 0.05. So therefore we would say yes, because a total malfunction will not be impossible, but it would be unlikely.